In Module 3, we're going to be looking at two of the biggest pieces that we can take away from this course. So the first is confidence intervals. So this is where we say, okay, I want to know something about the population. I want to know the mean or the proportion for the population. But if we can't talk to everyone in that population, then we take a sample. So we've talked about sampling in the earlier parts of this course. So we take a sample and we either get a sample mean, x bar, or we get a sample proportion, p hat. And with either of those, right, it's a sample, so we know it's not going to be perfect. The real value, the real population value, the parameter, is probably not going to be exactly those values that we find. And so what we do is we build an interval. We say, okay, depending on a certain level of confidence, and so we'll see this in the course material, 90% confident or 95%, we're going to build in a little margin of error. So we're going to say, okay, cool, here was my sample value, but I'm going to build in a little cushion, so plus or minus m, some sort of margin of error, to say, okay, hopefully now that I've built in this cushion, I'm going to trap the real value, the true value for mu. Right? Hopefully. We don't know for sure that it traps mu, but that's where the confidence comes in. The same thing is true for p and p hat, right? We're hoping to trap p, the proportion for the entire population, so the parameter. We take our sample, we get p hat, and then we say, well, plus or minus some margin of error, again with a confidence associated, and we say, hopefully that thing traps the real value, p. So again, these are called intervals because we have a center point here with our point estimate, and then we're building out in each direction. So we're creating an interval, and when you do this in your calculator, it will give you the interval as the lower bound and the upper bound. Confidence intervals will also show up in Module 4, so you get a chance to see this with one sample mean and one sample proportion. Module 4 you see it with two sample means, two sample proportions. Okay, the second major thing that we look at, and again this will show up in Module 4 as well, are hypothesis tests. So the idea here is that we might suspect something about the real mean or the real proportion. That's what's called the null hypothesis, or in this notation it's h with a little 0 here, so h null or h naught, or sometimes you see this h0. So there's a few different ways to say that. So this is what we're assuming to be true, or what we believe to be true, or what used to be true, those kinds of things. So if there's some value for mu that was either true of the previous population, or again, we suspect that it might be the case. So we might suspect, okay, we're going to assume that mu is equal to 10 or something like that. So the real population mean is 10. There might be some reason to believe that that has changed. So this could be data from one basketball season to the next. So maybe last season this was the value, and we think that this season the mean has gone up. So we think this season mu is greater than 10. So this is what we're testing. We're trying to find evidence for this. We call it the alternative hypothesis. So that's H with a little a down there. So the alternative hypothesis is what we're trying to build evidence to show. And we walk through, there's an entire process on this basically saying, at what point am I allowed to say, yes, the alternative thing is true? But the null is what we're assuming to be true. That will always have an equal sign in it. And that's whether we're doing means or proportion. So we could have a similar thing, null and alternative hypotheses for proportion. So instead of mu, we would use p. Again, the null hypothesis will always have p equals something. So we have some reason to believe that maybe the proportion is 0.75 or 75%. And then maybe it's the case that we're not really sure if we're going to get 75%, we're just trying to figure out if it's 75% or not. So we could say something like not equal to 0.75. So if we have a reason to believe the value has gone up or gone down, we could use greater than, less than. If the language of the problem doesn't say that, or if we're just thinking maybe there's some kind of difference, some kind of change, we'll say not equal to. So these are the two big things that we look at in Module 3. Again, we'll have some resources to go along with this, but please do start early on this because this I can almost assure is new information to you, so it can take a little while to digest this. So make sure you're starting early, asking questions, and really getting this down so that when we see it again in Module 4, things are much smoother as we close out the course.